Hello wonderful people. In this presentation we're having a look at project management, which sounds terribly dull but is actually really important and one of the key concepts in the software development process. So our learning intention is that students can explain the key features of project management. So what do we mean by project management? Well, project management is about planning and tracking the use of your resources over the life of a project. In our context, a lot of those resources are the human resources and you are that human resource. But we're trying to learn about it in a larger context in terms of how it's done in a professional setting. So we've got 6 key concepts. The first key concept is the identification of tasks. Then we have the sequencing of those tasks, the time allocation of each task, the dependencies, so what has to happen before something else can happen, or more to the point, what is task B dependent on before we can start or finish it, milestones, and finally the critical path. So let's have a look at these one by one. So when we're looking at the identification of tasks, we're identifying the resources. So we also just don't want to be blindsided by just going, oh yeah, we need to do this thing and it slipped my mind. Particularly when you've got a number of people working on it, but even at a personal level, it's important to know, well, I'm going to need time to do this. And I think as you do your SAT, you're going to find keeping your eye on all of the tasks to actually be one of the most challenging things. You also want it to be able to consult key stakeholders. Some of these will be the people who are paying for the project, some of these will be people who are impacted by the project, but this document, this sequencing document or the project management is a good way to socialise what it is you're doing and what will be required. This allows you to check the availability of human and other resources. For example, you might need the testing team to be available to you for all of June. In the professional environment that I worked in, it wasn't uncommon to have 30 or 40 projects happening at once. It was quite a large organisation. So you couldn't assume that just because you wanted testing done in June that it was necessarily going to be automatically available to you. You know, we're talking about a considerable cost for these people, and you can't just invent software testers. So you have to fit in with other schedules. And also it's a key tool for budgeting. If you know how many human hours you need, what those hours are, what sort of technical requirements you need, you're a long way towards having an idea of what the budget is. And the budget for these projects can be substantial. In fact, I would say in a professional environment, they're always substantial. Then we've got the issue of sequencing. So there you go, I've skipped ahead. First of all, there is just a logical sequence. You know, we can say, okay, well, we need to do our alpha testing before we need to do our beta testing. We need to get our requirements ironed out with the customer and information collection from our users before we write the SRS and the functional and non-functional requirements. It also helps you identify the dependencies when you're sequencing and saying, oh, hang on, we can't do this until we do this. Now I'm going to come back to dependencies. It just helps us establish the timeline that we say, okay, we know we need, and I'm going to come back again to the example of testing, we know we need testing. When, more or less precisely, are we going to need it? In the environment I worked in, I would go out and train people in call centres, and I would actually have to book probably a month, at least 2 or 3 weeks ahead of time. I couldn't just pop out there and deliver the training because it was quite disruptive to the running of the place. They had to have other people on the phones and the computers while people were in training with me. So I would need to book them. And so I would need to know, well, when is the project going to launch and when am I going to have enough information to train them? And so you actually had to be pretty precise about it. And if the project slipped, which we're coming back to, that could have significant impacts. And just scheduling. And again, that's the point I more or less just talked to. So time allocation. So we've got our tasks, we know what order they go in, but we want to establish actually how long they take in the timeline. This is often measured in hours or days, and sometimes the software lets you say, well, these are our working days. And it lets you start doing some scheduling and say, okay, well, we're definitely going to be able to do this in this time and this is how long we have to do it. And you can talk to your stakeholders and say, can you test this in 5 days? Can you write the customer support material in 5 days? And so forth. We also use this time allocation to track the progress of the project so that we can actually say, oh, you know what, the times have been blowing out. We're not going to hit this on time. We need to take action now, rather than realising, hey, we've got all these people sitting around that we're paying for and we can't use them yet. So it becomes really important in terms of staying under budget and on time. This often goes into a thing called a Gantt chart, which I'll have in a separate presentation, or a thing called a work breakdown structure, which we're probably not going to use, although you can choose to use that in your SAT, but most people choose to use a Gantt chart. So how do we estimate how long something takes? Well, there is just expert estimation. You know, when I was on some of these teams and my job was organising customer support, they would say to me, well, how long do you think you'll need to roll it out in the call centres? And so they would rely on my experience and my knowledge. Historical data analysis, we could say, okay, over the last 15 projects or even the last 5 projects, how long did it typically take us to do a project of this size? And often expert estimation is based on that sort of thing anyway. And then this thing called a 3-point estimation. What is the optimistic? You know, oh, we should be able to knock this over in 2 days. Pessimistic, okay, if this turns out to be really thorny, it might be 6 days. And the most likely scenario. And I would say in most cases, people are using the most likely scenario. Then we come to this thing called the critical path. The critical path is basically the things that line up with dependencies, so that if I can't do B until I've done A, and I can't do C until I've done B, and this is not how this always works, by the way, but if that were the case, if B blows out, then C gets pushed back and the whole project's going to run late. Some things aren't on this critical path. If they slip, it's okay. There's not something waiting on it. Think of it as a little bit like if the bus can't leave until everybody gets on it. So that person is on the critical path. But if the bus can leave without them, well, then they're not on the critical path. The work still needs to be done. It's not about what does and doesn't need to be done. But if something's on the critical path and it's slipping, then you're going to have to get that time from somewhere. You might have to push the date back. You might have to squeeze something else. You might have to pour more money and people into it to get the critical path back on the right thing. But it's actually quite important in lots of organisations to get something done on time. If you read the papers, you'd think that was never true. So it's the longest sequence of dependent projects in a task. Most software can actually track this for you. And the tasks on this path cannot be delayed without impacting the project completion time. It's calculated using network diagram techniques. As I said, most software will actually do this for you. And it helps project managers prioritise and monitor crucial activities. So, you know, if you've got something on the critical path and it's starting to slip, this is something that the project manager will be all over. I talked before about dependencies. Dependencies are just what they sound like. B depends on A. So this is the most typical thing, finish to start. A must be finished before B can start. Start to start, B can't start until A has started. You can have that as a dependency too. And you can have these things must be complete together. I have to say I don't see that very often. The one that you will most often see is finish to start. Now this is a Gantt chart. I'm going to have a different presentation about this in detail, but if you look at that line there, that's actually saying that develop project plan can't start until we have finished creating a problem statement. So that's what that arrow means. Sometimes the software will produce a red arrow and people are just like, oh, I don't know why that's red. Well, why that's red is that you've actually said that you can't do this one until you finish that one, but this block is over here in the same time. So you're saying that they're dependent, but you're not treating them as if they're dependent. So if it genuinely is dependent, then you actually can't do it until it's done. This is what yours will look like, and demonstrating the dependencies is a key part of what your Gantt chart needs to do. Finally, second final, maybe finally, I can't remember, let's find out, is a milestone. So a milestone is a specific moment in time. It normally doesn't consume resources. It's not actually a task. It's more like finishing a stage. It's like getting to the end of a level on a game. You don't have to, once you're there, you just get all the fanfare of moving on, but you're not actually having to solve any additional challenges. You'll normally have 3 or 4 of them during the course of a project. It marks the completion of a phase of the project. It helps track the project. We can say to everybody, okay, we're at the end of development. We're now moving into evaluation. Sometimes people will have a celebration. There you go. That in fact was all the concepts. So the concepts were the identification of tasks, the sequencing, the time allocation, the dependencies, the milestones, and the critical path, although I appeared to have them out of order the way I presented them. So let's just test your knowledge. If I was doing this in class, I'd do this on Game Show. If a task on the critical path is taking longer than expected, what impact will this have on the overall timeline? Well, it's going to push out the timeline, is the short version. If the project plan is valid, and something on the critical path is taking 6 days instead of 5 days, then that project is going to complete a day later unless accommodations are made. That is the simple truth of that one. What can you do to manage the project when a task on the critical path takes longer than expected? Well, you can spend more money and put more people on it to get that timeline to shorten again. You might have to pay people overtime. You might de-scope something. You might say, well, in order to get to the end, we're going to have to make this project smaller. That's a thing that happens. Another thing that you can do is you just accept that it's going to ship late. That's quite unpopular in organisations. People feel like it's a real black eye when something ships late. But those pretty much are your options. You could also try and squeeze it out of another deliverable, but often that means spending money, because if somebody told you it's going to take X days, then they really think it's going to take X days. You telling them to take X minus 1 or X minus 2 days is not always achievable. In fact, I'd say it's often not achievable. If we did not sequence our tasks, what risk could this introduce into the project? Well, I would argue that it's extremely likely, particularly if multiple people are working on it, but even if we're the only person working on it, that we're going to miss things, that we're just going to get caught, that expression about not being able to see the wood for the trees. That's what we get into if we haven't sequenced our tasks. Well, like, I'm doing this and I'm busily writing code, but I forget to do important things, or I'm not ready. I don't have the resources ready when I need them. How can we most accurately predict the time that each task will take? Well, short version is expertise and history. You've also got that optimistic, pessimistic, and most likely, but I think they tie back to expertise and history. And that's the end of this presentation. I hope you found it useful, and I'll see you soon.